So I'm going to be talking about this study that we've been doing in the Sigma Orion cluster, looking for external photoevaporation of protoplanetary disks. So Sigma Ori is located in Orion, very close to the Orion belt stars and very close to the Horse Nebula. So it's a very good place to study external photoevaporation because at the center is this massive multiple OB system that we believe is affecting the evolution of nearby protoplanetary disks. So we study stars in Sigma Ori using spectroscopic data, so mic spectra, looking for optical forbidden emission lines like the oxygen 1, nitrogen 2, and sulfur 2 lines that have been related with photoevaporation. So here I show you some of the examples of our spectra for our stars. The sample of our observations were 19 T-tauri stars, so low mass stars. The resolution of our observations is 10 kilometers per second, and you can see that we found of these stars, 13 stars are detected in the oxygen 1 line at 6,300 Armstrong. Is the most common and prominent line. As you can see here, we have identified the profiles of the line, we have fitted the profiles and looked for the low velocity component of the lines and also the narrow component of this low velocity component, which is usually related to photooperating winds. So we have estimated some line ratios for the stars that were detected in both of these lines, and we found a mean value of 0.2, which is consistent with previous work and is being related to FUV photodissociation of OH molecules. So we now looking for all the lines, and we fitted all the lines, and we're now looking for different properties or different relationships for our stars. So in the accretion properties, we have estimated accretion rates of the using the H-alpha line, and our sources are consistent with low accretion rates, and we do not find any correlation with the stellar parameters. So we don't find any correlation of the luminosity of accretion with a stellar mass or with a stellar luminosity. And this is also being found in other works. So if you look at the luminosity of the oxygen 1 line, only taking the low velocity component, here I show you the luminosity of the oxygen 1 line for the different oxygen 1 lines of different colors, and we highlighted the narrow component using the star symbol in this plot, and we didn't found any correlation between the luminosity of the oxygen 1 line and the luminosity of accretion. And if you can see, the billing of our stars is very low for our sample. So this is expected if you believe that the oxygen 1 line is being produced by other processes rather than accretion. So if you look at a more interesting relationship, for example, with the distance of Sigma Ori, so this distance is the real distance to the OB massive system taken from the parallax of the diagram that reads 2. So if you look at the luminosity of the oxygen 1 line, again, only the low velocity component, you see a possible trend with distance to the central OB system, which is consistent with photoevaporation. This relationship is less clear with the equivalent width of oxygen 1 line, and we find this very peculiar object, SO341, which is like an outlier in our sample. It's very bright, it's detected in all the lines. But if you look at the submillimeter data done by this work, Hansdale 2017, using ALMA 1.3 millimeter, they estimated dose mass and they find this beautiful relationship that more massive disks are more distant to Sigma Ori. So if you look at the brightest source in our sample, in the submillimeter is this source 540, is a transitional disk, so it's expected to be bright. It's also detected in CO, and you can see the spectra that they have this beautiful emission at oxygen 1 line, and it's located at 15 parsecs from the central massive system. But if you look at this other peculiar object, it's not the more massive one, it's even more distant to Sigma Ori, so it's located at 25 parsecs, and it has this huge emission at oxygen 1 line, very bright, brighter than the other one, and wider. So this is not what we expected, but we are looking at different alternative possibilities for this source. Maybe the line is not induced by external photoevaporation, but maybe for local conditions like a very active chromosphere. So we are having these very interesting results. So stay tuned, and I'm looking very forward to meet you all in this conference.